Okay, this lesson on reference angles really is a follow-up or the second part of the previous lesson on trig ratios for any angle. What we're going to do here is using the three special angles of 30 degrees, 45 degrees, and 60 degrees, which remember is pi over 6, pi over 4, and pi over 3. Using those special angles, we can find the trig ratios for many more angles. And by finding the trig ratios for many more angles, I mean being able to, without technology, give exact trig ratios for many, many more angles written in standard position. So if we think of theta being a non-acute angle in standard position, its reference angle, theta prime, so this looks like an apostrophe, and we say theta prime, is formed by the terminal arm of theta and the x-axis. So in the previous half of this lesson, you'll remember that we dropped a vertical down to create a little right triangle. And so theta prime is this new little angle that's inside the right angle. Okay, so we call that theta prime, or the reference angle. Okay, and it sits inside that triangle. You're always dropping your vertical to the x-axis when you're doing this. So in this case, theta prime is the angle that makes this original angle theta go up to 180 degrees. In this case, theta prime is here, so it takes that angle theta down to 180 degrees. And in this case, theta prime, the reference angle, brings us up to the 360 degrees. Okay, so this is in quadrant 2, 3, and 4. So wherever you have a non-acute angle, you can drop a perpendicular to the x-axis and create theta prime, our reference angle. It's important to note that the reference angle is always acute, and it's always considered positive no matter where it is. We're just measuring its size. Okay, so in this case where we're in quadrant 2, and I really should be writing that in Roman numerals. Okay, in this case, you could take 180 degrees and subtract theta to get theta prime. Okay, so you could do 180 degrees minus theta. Or when we're working in radians, we could say pi minus theta. In quadrant 3 here, we could take our angle theta and subtract pi, or subtract 180 degrees. Okay, so really these both are taken care of by the absolute value of the difference of 180 degrees and theta. And in quadrant 4, our reference angle is the difference between 2 pi radians and theta, or 360 degrees and theta. So it'll be 360 minus theta, or 2 pi minus theta. Okay, so it's the difference between those two angles. Okay, so let's take a look at these now and just see if you can come up with the reference angle for these 6 angles. And again, you might want to press pause, make some intelligent guesses, and see if you can get them. Or if you're not comfortable doing that, just keep watching. But if you do pause, then just pause and check your answers after we get finished. So to look at 345 degrees, you need to have a good idea of where that angle is. So 345 degrees is in the third quadrant, and it's how many degrees from 360? It's 15 degrees from 360 degrees, so our reference angle will be 15 degrees. 5 pi over 6 is going to be, in our second quadrant, it's 1/6 of a pi up from a whole pi of 180 degrees. So it's 1/6 up. So that's reference angle will be pi over 6. Negative 135 degrees. Well, that's negative. Going a bit further will give us negative 135. So how far is that from 180 degrees? It's 45 degrees from 180 degrees. So our reference angle will be 45 degrees. 2.5. Notice there's not a degree symbol on there, so um, it does mean radians. So 2.5 radians, well, all the way to 180 or to pi radians, halfway around our rotation is going to be pi, so 3.14. So 2.5 is going to be somewhere in the second quadrant. So our reference angle will be this difference. So our reference angle will be pi minus 2.5 as an exact reference angle, or we could say it's approximately 0.64 if we take 3.14 and subtract 2.5. For 580 degrees, 580 degrees takes us all the way around and more. So let's think about how much more. Find the coterminal angle that's less than 360 degrees for 580. So we do that by subtracting 360 and we get 220 degrees. So we're going around once and then 220 degrees more. So there's 180 degrees more. So we're going a bit further. So we're going that far, so we need this distance here. So it'll be the difference between 220 and 180. So our reference angle will give us 40 degrees. Same with 8 pi over 3. We're going more than twice, or doing more than 2 pi, more than a full rotation. So if we subtract 2 pi, that'll be 6 pi. 6 pi over 3 that we're subtracting. So we end up with 2 pi over 3. So it's coterminal to 2 pi over 3. And where is 2 pi over 3? Well, 1/3 pi is here, 2/3 pi is in here, and the difference between 2/3 pi and 1 pi will be our reference angle. So our reference angle theta prime will be 1 pi over 3. Okay, so once you know how to calculate what the reference angle is, here's how reference angles actually work. Okay, the trig ratios for theta are the same as the trig ratios for theta prime. Okay, so for every angle all the way around the Cartesian plane, the trig ratios are equal for theta as for theta prime, except possibly for the sine. Okay, since theta prime is acute, okay, it's less than 90 degrees, all the ratios are positive. But we know that for theta, as we go work our way around the Cartesian plane, as we work our way around that circle, we know that some of the ratios are negative. So we need to put together the value. We get our value for the trig ratio from theta prime, but we get the sign by remembering this, okay? All are positive, sine and cosecant are positive, tangent and cotangent are positive, and cosine and secant are positive. We need to remember where they're positive and where they're negative. Okay, so let's do a couple of examples of practice so that you can see how we put these in use. So when I say find the trig ratio, find the sine of 135 degrees, I'm saying I want the exact value, not a rounded value, and I don't want you to use technology to do it. So we're not using calculators to do this. We're using our charts with the 3 special angles on them, and we're using the cast rule or a smart trig class rule to find out where things are positive. So for the sine of 135, what's its reference angle? So theta prime is going to be, and it's helpful to make a quick sketch, 135 is going to be in here, and it's 45 degrees from 180. So our reference angle is 45 degrees. Sine, this is quadrant 2 where sine is positive. So the sine of 135 is going to be positive the sine of 45. Okay, so it's going to be equal to the sine of 45 degrees, which from our chart is root 2 over 2. So if we look now at the cosine of 4 pi over 3, let's make a quick sketch so we know exactly where that is. If we go around, there's 3 pi over 3, so 4 pi over 3 is that much further. Our theta prime is this angle here, which is going to be 1 pi over 3. So our theta prime is pi over 3. In the third quadrant, cosine is negative. So the cosine of 4 pi over 3 is going to be negative whatever the cosine of pi over 3 is. And the cosine of pi over 3 is 1/2, so it's negative 1/2. Okay, so we're using two different pieces of information. We're pulling them together to be able to find sine and cosine of lots of different angles around the Cartesian plane here in standard position. So the cotangent of negative pi over 3, here's the first negative one that we're dealing with. Well, if we go negative pi over 3, we're right there. Okay, so our reference angle is the same size, but it's considered to be positive, so it's pi over 3. Cotangent, this is quadrant 4, where the cotangent is negative. So the cotangent will be negative, whatever the cotangent is for pi over 3. So on your chart, take a look at what the tangent for pi over 3 is. And I believe you'll see that it's root 3. So then the cotangent will be 1 over that. So it'll be negative 1 over root 3. But when we rationalize that, we will get negative root 3 over 3 for our cotangent. And that's it for this little second part of that lesson.